Hi there, today we're going to be looking at equations with brackets on both sides. Here is our first example. Solve this equation. 4 bracket t minus 2 equals to 2 bracket 1 plus t. On the left hand side we have a multiplier of 4 and on the right hand side we have a multiplier of 2. The common factor here is 2. Let's first divide both sides by 2. On the right hand side we'll be left with 2 bracket t minus 2. And on the right hand side we'll be left with 1 plus t. Our first term is 2 multiplied by t, which gives 2t. Our second term is 2 multiplied by negative 2, which will give negative 4. Here we want to group the like terms on one side. Let's first start by moving the term with t by itself. To do this, we need to do the opposite operation, which will be subtract t. We will then have 2t subtract t minus 4 equals to 1. 2t minus t gives t. We'll then have t minus 4 equals to 1. To get t by itself, we need to move negative 4 away. To do that, we'll plus 4 to both sides of the equation. We will then have t is equal to 1 plus 4. Therefore, t is equal to 5. We can check our solution by substituting it back into the original equation. Our original equation is 4 bracket t minus 2 equals to 2 bracket 1 plus t. Let's first start by substituting t is equal to 5 to the left-hand side of the equation. The left-hand side is 4 bracket t minus 2. We will replace t by t is equal to 5. This gives 4 multiplied by 3. Our left-hand side is 12. On the right-hand side, we have 2 bracket 1 plus t. Instead of t, we are going to substitute t is equal to 5. We'll then have 2 multiplied by 6. The right-hand side gives 12 as well. Therefore, the left-hand side equals to the right-hand side. This is how we know t is equal to 5 is the correct solution. Here is our second example. Solve this equation. 1/4 bracket t plus 1 equals to t minus 5. The left-hand side of the equation can be rewritten as 1/4 multiplied by t plus 1 divided by 1. We can combine this into one fraction. The numerator becomes t plus 1 and the denominator becomes 4. To remove 4 from the denominator, we'll multiply both sides by 4. We will then have t plus 1 equals to 4 lots of t minus 5. We can then expand the brackets on the right-hand side. We'll then have t plus 1 equals to 4t subtract 20. We'll then group the like terms together on one side. Let's first start by moving t to the other side. To do this, we'll subtract t on both sides. We will then have 1 equals to 4t subtract t minus 20. 4t subtract t gives 3t. We'll then have 1 equals to 3t subtract 20. We need to get the term with t by itself, so we need to move the 20 away. To do this, we'll plus 20 to both sides of the equation. On the left-hand side, we'll have 1 plus 20, and on the right-hand side, we'll have 3t. 1 plus 20 gives 21, so we have 21 is equal to 3t. The last step is to move the 3 away. At the moment, we have 3 multiplied by t. We need to do the inverse operation, which is divide 3. Therefore, t is equal to 7. Here is our final example. Solve this equation. 3/4 brackets t minus 5 equals to t plus 3. We can rewrite the left-hand side of the equation by writing 3/4 multiplied by t minus 5 divided by 1. This will give 3 bracket t minus 5 divided by 4 equals to t plus 3. We want to remove the denominator 4 by multiplying both sides by 4. We'll then have 3 bracket t minus 5 equals to 4 lots of t plus 3. Since there are no common factors between 3 and 4, we need to expand the brackets. On the left-hand side, we'll have 3 multiplied by t, which gives 3t. 3 multiplied by 5 gives 15. 4 multiplied by t gives 4t, and 4 multiplied by 3 gives 12. Next, we need to move the like terms together. Let's first move 3t over to the other side. To do this, we'll subtract both sides by 3t. We will then have negative 15 equals to 4t subtract 3t plus 12. 4t subtract 3t gives t. We'll have negative 15 equals to t plus 12. To get t by itself, we need to move the 12 away. To do that, we'll subtract 12 to both sides of the equation. We will then have negative 15 subtract 12 equals to t. This gives t is equal to negative 27. To check this answer, we can substitute it back into the equation.